Welcome! In this video, we are going to look at problem 3 from Chapter 19 of College Physics 2E by OpenStax. Okay, so we have a bare helium nucleus. It has two positive charges. We know its mass. We need to calculate its kinetic energy in joules if it's moving at 2% of the speed of light. We need to convert that to electron volts, and then we need to figure out what potential or what voltage potential difference would be needed to obtain that energy. Okay, let's start with what we know. Okay, we know the charge. It's positive charges, and there's two of them, so that's 2 QEs, or 2 times 1.60 times 10 to the minus 19 coulombs. We know the mass is 6.64 times 10 to the minus 27 kilograms. We know the speed is at 2% of the speed of light. So we'll put the 2% in decimal form for 0.02 times c. And then we know c, the speed of light, is 3 times 10 to the 8 meters per second. Okay, we need to find kinetic energy. Well, kinetic energy is 1/2 mv squared. All right, so that's 1/2 m. M is 6.64 times 10 to the minus 27 kilograms. The velocity is 0.02 times 3 times 10 to the 8 meters per second. We need to square that. Okay, I did this calculation. I got 1.195 times 10 to the minus 13 joules. To 3 sig figs, I called it 1.20 times 10 to the minus 13 joules. Okay, so there's the kinetic energy. All right, in part B, we need to convert that to electron volts. Okay, so we have 1.20 times 10 to the minus 13 joules. Let's set it equal to itself. And now let's do the conversion. In 1 electron volt, there is 1.60 times 10 to the minus 19 joules. Okay, we find it is 7.47 times 10 to the 5th electron volts. Okay. And now part C, we want to know what is the voltage or potential difference. So we can think of this as starting with full potential. So all the energy is potential energy. And then the helium particle or helium nucleus is going to travel through the potential difference. All the potential gets converted to Ke. So at the start, there's no kinetic energy. At the end, there's the kinetic energy we found. At the start, it's full potential. At the end, the potential is 0. Okay, so we know potential. Change in potential is the change in potential energy per charge. And so we can say the change in potential is the change in kinetic energy per charge. Okay, so our delta V is the kinetic energy we just found, 1.20 times 10 to the minus 13 joules, divided by Q. Well, Q was 2, there's 2 of them, so we're going to have 2 times 1.60 times 10 to the minus 19 coulombs. this gives us 3.735 times 10 to the 5th volts. So we can say our delta V is 3.74 times 10 to the 5th volts. Okay, I hope you found this helpful. Let me know in the comments section if you have any questions or if there's any other problems you'd like to see. Thank you for watching. Please like and subscribe, and I will see you in the next one.